Maybe this works. Hotel in Nishkal. You can ask something, but let's say the second derivative of that is 0. Did I do that correctly? Doesn't look like it. Yeah, it's 2 divided by 6, 1/3. Okay. Yeah, these I've been struggling with this for so long now. This is really one of those cases where you want to be 100% sure that everything that you did is correct. Please, no errors. So I have to verify this. So first of all, if you fill this in, what do you mean? It okay? Plus? Yeah, okay, it's one, yeah. I mean, it's like 100% sure already. I don't have to test it, basically. No, I don't have to test it. This is correct. So if you fill this in here, then this is definitely 302, so that is going to be 0. And an alternative way is to calculate, so let's say, more alternatively, Ix is, from the top of my head, minus C2 divided by 3 times C3. Though actually there might be a 2 here. Okay. See, now I'm having a problem with the minus. No, I do not. Minus 151 divided by, sorry, it's 3 times C3. Okay, now we want to do a conversion to, let's say, something called XS, because I used that elsewhere already. So we want to end up with an, let me peek how I call that. I went from P to f of x, sorry, f of XS. Is it plus or minus xi? Yes, so I want in the current coordinate system with x, I want to have that if x equals the inflection point, Then in the new coordinate system, the inflection point must be at 0. Therefore, my new xs, that is the x-coordinate of the new coordinate system, must be 0. If the x equals to ix in the previous coordinate system. So these two correspond. If x equals ix, then xs must equal 0. So that gives me a relationship where I can express x in terms of xs. So x equals xs plus ix. So the function of xs, which must be the same thing as px, well, the only thing I'm shifting x, so the y value doesn't change. No scaling or shifting there. We just replace the x here with xs plus ix. And we can fill that in P. So you get this. Yeah, the x is replaced with this. And then I'm not daring to use formulas. I tried that before. I really just want to use an example, hard-coded example values now. So we just fill this in. This equals this plus xi, which is equal to that. And then we can make a polynomial of that. I'm not going to do that by hand though. Let me just go here, I think. So we have a symbol of xs. The f of fx, sorry, the f of xs, yeah, is that thing. But this must be a normal square, and this must be, oh, that's the only thing we have. What? No, I miss to the power 3 here. Also, it doesn't like floating point values. I will have to replace this with a rational. So that came from 151 divided by 3. So you can make Sims 151 divided by 3. I think that should work. Still a syntax error. Oh, still a dot. Oh, it's sim. Yeah, there was an example here with... My example is gone. Maybe it was sim. Yeah. The sim of symbol. Display, I want to print it as a polynomial in XS, so I'm just gonna type collect, expand, simplify the whole shebang, fxs, to simplify fxs, expand it, and then collect xs. So this is what we get for here. No, I guess I can keep writing that as rational. Stupid music thinks that I want to hear anything with vocals in it. Better. Yeah, so by this well, by shifting it horizontally, so that the inflection point becomes at the position of x equals 0, you get rid of the square thing, so the xs square is not there. Now next I want to find where for this polynomial there are the extremes. So we need to calculate the derivative of this. And then you have to solve. Set this to 0 and then solve for xs. Yes. Bring this negative thing to the other side and then divide it by 3. Then we get this divided by 9 and then the square root. Plus or minus that are the solutions for this equation. Saying a numerical value to that. What? I saw this number before. That's interesting. Confusing also. Yeah, okay. So now what I want is to convert again to another coordinate system in order to get a new function x of xt such that the extremes end up at plus or minus 1. And now they are at plus and minus, well, 41, say. So we have to divide by this number, right? So x must be divided by the number, or xs. Let's copy something like this. So I'm gonna do let xt is xs and then I don't know, times or divided. I guess divided, yeah? Yeah, divided. So that if xs equals that, I mean you'll pick one, we'll just pick the plus here, then xt is 1. And from that follows that xs equals that number times xt. Therefore, you can write that the g of xt equals f of xs, which is just this. And then we can fill that in this. So that is this times this number plus xs, which is that, to the power 3. I think I'm missing an xt here. This one. Okay, so we just take this one and then fill in xs, fill that in. Let's add a dot here, multiplication. So this xx to the power 3 becomes that to the power 3. And here we have that xs becomes this thing, and then multiplied by that. It must be subtracted from this constant. Okay. Now we can work that out. Well, this doesn't change, assuming you can't divide this number by 3. No, it's not divided by 3. And yeah, this is let's forget about the rationals, I would say. Might as well work it out then. Okay, so what is this? It's that number. Did I hit enter in the other case? Not convinced. Looks a little bit small for this. Let's do that one again. Oh, yeah, totally different. Copy. Minus that. Minus that. Hopefully I did not make a mistake. Right, so I'm not really convinced that this is 3 times that value. It should be. 3 times this is maybe. anyway, you can type the root of tx are the same as the roots of h of xt being equal to g of xt divided by this. I just make it a monocle polynomial. Three. Good. Totally missing a .xt though. Yeah, even I recognized this number, so everything went well. The roots of h of xt are I solved that before, but let's do it again. Let's do it in octave. Start over. So you have some function of x equals that. To the power 3. It must be a thingy, and this is just a number which is not allowed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait a minute. So I have to divide this by a 1 with 11 zeros, yeah? Just talking about floating point things. What a bullshit. What the hell does this contain complex numbers? Seriously. Okay. The complex numbers disappeared, so we just have three real roots. Oops. Now what I failed at so far is converting these numbers back to the actual roots that we started with. These. So what do we have to go through to convert these things back? Now that last division didn't change the roots, so we can ignore this. But here we did a scale. And I guess we are now at xt, and I want to go, this is in xt, yeah? Yeah. So I want to go to xs, which means we have to multiply xt with this number. So we multiply it back. Multiply with so we get multiply this times first one. Oops. First one. That's not even close to an integer. Also lost a gazillion load of accuracy, but this is because these things are rounded off. Damn it. I'm pretty sure that this is just 1/3. So just make this lots of 3s, because I think that's what it is. So 6. Right. But despite taking care of the floating point round-off error, we still didn't get back what we expect, namely minus 13. 76. Moreover, I get 2 negative roots. And here I have only 1 negative root. What the hell is going on? Now we still have to shift them, so maybe one of the negative ones becomes positive. So let's pretend nothing is wrong. Actually, maybe we can look at the difference of the two largest, so the two ones that are far apart. So the distance between these two is this plus this minus that, and that is 90. That's the difference between these two. Okay, it gives tiny little hope. Although I thought I had the outer one, but no, I did the negative one. What? No, this is possible. Yeah, this is not the outer one, man. This one is the one that is furthest away. Okay, it seems to go work. Actually, I had these numbers before, and then I gave up. That was not. I should not have done that. It's correct. I now believe. Yeah. So next, we have to add stuff, right? Because this must become larger. So shift. Yeah, of course. Shift back by adding 50.333.23. And that's so totally, yeah, that is working. Wow, man. These are negative, so the floating point stuff disappears. And this becomes 50 minus 13. That is 37, I guess. And this is, yeah, minus 13. And this one becomes one more than 127. There we are. You got the roots back. Phew. Okay. So it did work. Okay. Now I had another case, namely the case where there's only one root. That gets extra complex. Haha, pun intended. So I think I want to keep this one, which is the furthest away. But the other two must magically turn into something else, such that I have no clue. Hey, Amon. Still struggling with this. What should I do with the two roots? Such that they are no longer real, but for the rest they have the same magnitude. Doesn't it sound like I just should use minus 13i and 37i? So it could of course be any complex number as long as it's, let's say the norm of the complex number is 37, but it's not 37 itself. But then if you multiply it with the other one, it has to become a real number. Maybe there are multiple solutions. I'm not sure. Okay, I guess this factor is not interesting for that question. So you can ask ChatGPT to get some inspiration. Let's just start a new one. Yeah, so this is just a quadratic, of course, with the roots a and b. But I don't want the roots to be real roots, so I'm saying that a and b are complex and their imaginary part is not equal to 0, because then it would just be a real root. But the whole quadratic must have real coefficients, so the whole thing is just real. And I also know the values of the absolute values of a and b. So furthermore, we know that the absolute of the norm of a is L, whatever, no, it's hardly readable, K. And the norm of B is M. Now let's use it S and T. I don't know. S and T, where S and T are, well, if you take the norm, it's automatically real, isn't it? So obviously real. Well, Kotayo, I'm not convinced, but maybe you're right. I mean, if the absolute values would be equal, then of course you were right. But I'm not sure if they are unequal. What the fuck? It makes them equal. So then I guess you're right. But why would that be the case? Again, it's not at the top. To solve this problem, let's start by examining the expression x minus a times x minus b, which is real for all real x. Since x is real, and a and b are complex numbers with non-zero imaginary parts, we can represent a and b as a is u plus iv and b is w plus iz, where u W are real parts and V and Z are imaginary parts of A and B respectively, with V is unequal 0 and Z is unequal 0. So for it got it. Expand the product. We expand x minus A times x minus B, and it repeats that, equals, it just fills in, I guess, A and B is filled in, and then we remove the parentheses. Great. And here too. And then it multiplies the real parts. And this is a multiplication between minus IZ times x minus u. And then we have minus IV times x minus w. And then, of course, the minus drops out and the I becomes a negative. And we have V times Z. So I agree with that, which equals okay, just puts the real parts together and the imaginary parts. I times x minus uz plus V times x minus w. Okay. It's not a wise choice, Ultron. Not a wise choice. It's not gonna help you. It's only will make it well. The longer you go on with it, the harder it is to stop with it again, or return on the path you took. You should seek help and then stop with that. X minus A times x minus B. To be real for all real x, the imaginary part must be 0. I think doing a lot of mathematics is a good alternative. I know I never did do self-harm, by the way, but I'm kind of half a psychologist. I dealt with kids that did that. And now I want to concentrate on my mathematics again. So yeah, this part must be 0. X minus u times z plus v times x minus w is 0. Yep. Simplify the equation. Z plus v times x, z times x, v times x, minus z times u and v times w equals 0 for all real x. Yeah, that's it. For all real x, that's only possible then if, I guess, this is 0 and this is 0. Since this must hold for all real x, the coefficient of x and the constant term must each be 0. That's what I thought. Coefficient of x, z plus v, is 0. And the constant term, z plus u plus v times w equals 0. Solve the system of equations. From the first equation, z equals minus v. Substitute z equals minus v into the second equation. I guess this one. Z is replaced with minus V. It dropped the minus also. Plus V times W equals 0, from which follows that minus VU plus VW equals 0. Divide both sides by V, since V is unequal 0. Minus U plus V equals 0, from which follows that U and W must be the same. And what was U and W again? That's the real part of A and B. Yeah, you're right, Gotthard, but please bear with me that I verify this. I don't know. My memory is degrading, and or I had a good reason for it. I don't know. I don't know. I didn't remember it. So if you don't remember it, then you have to derive it. But I'm slowly getting convinced that indeed it's just each other's conjugate. And now you put it that way, and that does ring a bell. Yeah. I've been so deep into cubics that even I dropped that one factor, getting a quadratic at the moment. I wasn't like, this is a quadratic. I don't know. Yeah, okay, I'm here now, and ChatGPT is completely right, and so are you. A and B must be complex conjugates. Equal real parts and imaginary parts opposite side. So, if I want to turn this thing into something with just one root, namely 127, then we can't obtain the 13 and the 37. We can't keep them. We'll have to use two complex roots here that are just each other conjugate and cannot have a different norm like that. Okay, let's start over. Okay, Kotaro, tell me, how can I combine the 13 and the 37 into these two complex roots, such that, I don't know, something is, and I can't think of the word, preserved, that's the word. Something is preserved. Maybe the derivative in the inflection point just flips. So we state that whatever the derivative is for this case at the inflection point, just change the sign, and that's it. And then no. Well, only one real root. So I'm not even sure that is reasonable. Well, it is kind of reasonable because at the edge where the two connect, you have a derivative of 0. Yeah, so if the derivative is 0 in the inflection point, that's basically exactly the point where it changes from having two extrema to having no extrema. Yeah, for the rest, it's maybe a bit arbitrary, so I'm hesitating to demand that it looks like that. There is something else I think I want, but what? Move the inflection because I want to. In the end, I think I just simply want to end up with a plus here. So I want to get some constant plus 3x plus xc to the power 3. No, I mean, this is, we have a root of minus 13 and a root of 37. Yes, and I want to change that to kind of, what is the word? Toegevoegde, or that's definitely a difficult word for it. Well, my feeling is that after the conversion that I'm going to do, we want to end up with exactly this thing, but then a plus here. So I could just work backwards and then see what it is, actually. Haha. If that is true, well, it can't be true because this one, which is this one, should survive. So the constant has to change as well. Okay, but from that one I can find the constant. Let's see, well, this one. So, yeah. I can find this constant from this one, which should survive. If I know that I want to have a plus 3 here. Let's see, how do we calculate that? To have this. This is readable, isn't it? I mean, it's small, but it should be as sharp as my own monitor if you look at YouTube. Okay, I'm gonna do the symbols is just xt. And then you have this thing, xt to the power 3. And this must be times, and this is a plus. Actually, I have another constant here, damn it. So let's call this c. Sims c. So you can make well, the new function is this thing. Let's set that to 0 and solve for c, and then fill in that one root. It's almost lazy if I do it like this. Oops. I wanted to fill in this one. Four zeros. Yep. So we replace xt with plus 1.8717. And then in this formula, and then we calculate it, convert it to a double. That should work, except if I have to add another. It's minus 12 point something. So it looks like that in the end we should end up with this plus 3 times x, like that. And now we convert this one back to the same way back as here. Then we magically will get the values for the complex root, I think, yeah. Let me verify though that this is indeed correct. I'm going to fill in here times and that plus again that to the power 3. Yeah, okay, 0 enough. I would have liked more digits though. Why do I not have more digits than this? It's probably a VPA thing. Infinite position. would have known that from the rest value would appear here as well. Okay, now we have exactly 0. So this is that value exactly even. If you assume that the other things are, that this is exact. Oh boy, no, wait, yeah, if you assume that this is exact, but of course it isn't exact. We're doing nonsense. I have to calculate that one more precise. This one is pretty precise, so we can just divide this by that to get it more precise. So that was a lot of 6's divided by that number. So this is a lot more precise anyways then. And then one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would be a 9. Okay, now let's go back from here to stuff. So I have to multiply it by this and then add that. That's the only thing that we have to do, right? But this is about x. So I have to replace. How do you do that? I think you have to divide by that now then. Or not. XS, yeah, I want to go back to XS. So this is XT. This is XT. It literally says XT. So we do is XT is XS divided by that. So I have to replace XT with XS divided by that. Yeah, I don't know. Is that true? So that thing doesn't even change value then. 3 divided by this number. And then 1 divided by that number to the power of 3. Such small numbers. I'm just diving in the deep, or walking in the dark. No idea what this is going. It looks so wrong. I mean, where's my 127? I don't see it back yet. But okay, I think the division was correct. I have no idea. Anyway, what do we do next? Add 50 something. That is also an X thing, right? No, I'm missing this vector. I am missing this vector. Or not. This vector here. Oh yeah, but it's this vector. 1 divided by this vector. Yeah, job. But it was a monocle before, right? So let me see. That was a monocle, just monic. I mean, so theoretically, I should have back my f of xs. This was xt, this is xs, yeah. But the real thing is monic, so we have to do f of x is, and then the coefficients divided by that number. I'm all lost as well, so don't worry about it. I'm going to divide this whole thing by that. Divided by this number. Yeah, even if you had not missed pieces, it would still be very hard to follow, I think, because I don't know what I'm doing. Plus well, not know what I do is maybe a bit too much. It's more like that consciously I don't know what I'm doing, but I trust my subconscious usually. So it's kind of like not knowing where you are because you forgot that, but you just keep walking anyway, and then for somehow you walk straight to home. Yeah. Okay, Kotaro, I'll explain to you what we did. So the idea is that before we have this, which has 3 roots. Yep. And now I want to keep everything as much as the same as possible, except that I want only to have 1 root, and well, the root that is the furthest away from the inflection point, which is at 50⅓, and I think that is further away from 50⅓ than this one. This is like 60 something, and this is, yeah, this is further away. So I want to keep this one, and then the other two must disappear. So how must they disappear? Well, I am shifting this so the inflection point is at x is 0, shifting it horizontally first, and then we calculated the where the extrema are, which then after you move the inflection point to 0, then of course the extrema are plus or minus the same value. So plus or minus 50, and 1/3 is then where the extrema are. So then I scaled the x-axis by 50 1/3, so that the extrema became -1 and +1. And I'm simply going to do the and then we divided the whole thing by some number in order to make it a monic polynomial again, which means that the highest term has a coefficient of 1. And then we ended up in this case with some constant -3 times xt plus xt to the power 3. And the -3 is not that weird, because if you take the derivative of this, then this disappears, and you just get -3 plus 3 times xt squared, which has roots at -1 and +1, which is exactly what we wanted. That is where the -3 comes from. And I think, well, now if now I want to end up with, I want to scale and shift and do stuff, and then end up with another canonical looking polynomial of the third degree, which only has one root, then it has to be a constant plus 3 times x plus xt to the power 3. That's half intuition. So just, I don't really have a good reason for that. I think I had an insight at some point somewhere a few days ago, and and then now the insight left me, but I still remember that going for the +3 is the right thing to do. So that's what I do. I want now to have a conversion such that we end up with some constant plus 3 times xt plus xt to the power 3. And for the rest, I want to keep things as much the same as possible, which means that I expect to multiply with the same factor. So now I started backwards. I start at some constant plus 3 times xt plus xt to the power 3. Now, how do we find this constant? Well, because we know that this root survives. Yeah, this root corresponds to the 127, and that still has to be a root of my polynomial. So if we do the conversion backwards, then that means that here we still need to use this, because you convert the 1.87 something back by multiplying that and then adding that, and then you get 127. So this is just linked like that. I mean, if this is going to be the same and that is going to be the same, and then we get 127, then we just have to start with this. So this must be a root of this cubic. Of this cubic. So that gives us the -12.70. If you fill in that 1.87 in there, then it's a root. This is 0. And really, if I do this, it goes up. I have no idea why. I just go back and forwards. What the fuck, dude? Who thought of that? Okay, anyway. Now we have the exact cubic. So now I can convert cubic back to the one where we can write it as something times x minus 127. And then we'll see what the conjugate complex roots are. Because we didn't know what they had to be. So what I want to conserve from this one is something from the 13 and the 37 that make up this vector and this shift. I think the shift is still the same, right? That's actually a good question. Yeah. I mean, I just envision the whole cubic as being something rotate. You have a line rotating around the inflection point, and let's say if it's negative, then you have an S form, and if it's positive, then you only have one root. And the inflection point doesn't change, so the shift is still the same. And I want to just, why not keep the vector the same? I don't know. I just want to see where I end up. So having this now, we replace the xt by xs divided by the same vector, and then you get this one. Make it monic again by dividing by that. And now we have to shift it such that, well, again, by adding the 51/3. So whatever the roots are of this thing, and then shift it. So this should be a root now. This should be a root of this polynomial. Let's check if that is true. Times plus that to the power 3. Close enough. I mean, if you have 836,518, then I consider that to be 0. So this is a root. Ta-da! That worked. And now I want to go from xs to x, so we have to replace xs with the relationship between these two. That is the relationship. So I fill in x minus xi, where xi was 50.333. So we're going to replace xs with x minus that. And then we get, is that G? I said x minus that. Yeah, minus that. Now, I have to work this one out again. As being a polynomial. Let's go to octave. Well, I guess I can just do this. Or is x not a symbol? No, I cannot do this. Totally not. Can I not have a symbol? No, you can't. Okay, it seems x. This is now Okay, 1, 2, 3, 4, 5, 6, 7, 8. Keep everything. This is 8. Nope. 1, 2, 3, 4, 5, 6. Text writing, yes, Discord. Wait, I'm not looking at Discord, but now I am looking at Discord. So you can type something in general if you want. Or did you have something else in mind? Oops, big. Can't put it here, like can't. Okay, just make it small like that, and it disappears. But now you can type here if you want. I hope I won't need that part of my monitor anytime soon, and I was going to move it away. Yeah, this is not really worked out, so we have to, let's say, we'll call this G or whatever. Probably more F. Display, I think T. Can you work this out? Why is it not floating point, man? I'm just going to do expand, I think. Expand G. And then collect. Yeah, I'll just put it on another monitor here. Until you have something. So I still see it. Right, so this would be the new go-to thing. And our hope is that this has a root of 127. So I guess I can just fill that in. Sure, I'm going to call that px, whatever. And then we do substitute. Subs. I thought it was subs. Substitute. Px, replace x with 127. Yeah. Immediately obvious that that is minus 127. No, wait, no, that's not what I wanted. I want 0, damn it. Okay, what's going wrong here? It's totally not 0. Or did I call this 0? Because this number is super big, isn't it? Yeah, that's close to 0. It's at like minus 0.12. I think I called that 0 before. Yeah, I mean, compared with this value, that's pretty much 0. A million. 6-digit precision root. So now I want to do a long division of this thing. Divided by x minus 127. Let's first copy it. So this is our x, was actually px then. Yeah, fx is the shifted one, but this is just px. We don't have a g, or the g is even below there. I don't know why I'm talking about g here. I think this is already px, right? Means a million. 1, 2, 3. 1, 2, 3. I think. Yes. Yep. And 0 is followed, so probably that is the exact number. Haha. And that is times, let's see, that's a constant. But there must be a minus in front of it. Actually, it's not, this is the precise number, and that looks very much the same. 121,738? No, maybe it's a coincidence. Though it would not be so weird if you just called integers, would it? Considering the original thing had all integers, we just did something incomprehensible to it. Okay, that was this constant. Probably. 1, 2, 3, and a lip. 1, 2, 3, 1, 2, 3. Yeah, this is definitely 1, 1, 5, 1, right? Squared. It's the same numbers here. Suspicious. So these numbers don't change apparently. That's pretty cool. Plus x to the power 3. So it changed from these two numbers to these numbers. We have a different color. Okay, well, what exactly do you want to do? Because now my whole workspace is... so give me a shout when there's something that we have to read. You can type formulas here. Okay, well, I bury it like this. So you have to tell me on Discord that if you have something to show that you can't type elsewhere. Our Discord has a LaTeX bot though. So theoretically it would be easier to type some mathematical formula there. This seems very lagged also. I'm not convinced that this is something that is super logical, because these just grew pretty big. If there would be integers, I would be more convinced. I don't know, man. But yeah. How do I do a long division here? This is my cubic polynomial. It's doing a long division. So we want to set R to 127 and then do this. Okay, so the result of that. So let's just remember this. So the coefficient of x squared becomes the coefficient of x to the power 3, and then the coefficient of x becomes the coefficient of x squared plus 127 times the coefficient of 3, or the previous coefficient, result 2, and so on. Can I remember this? I should be able to remember this one. Okay. So each previous coefficient rather becomes the higher coefficient of the cubic plus 127 times the higher coefficient of the current thing. So I already forgot if it was plus. Yep. So plus 127 times this one. But now I'm subtracting it. Sorry, I just want to keep the minus 150. This coefficient plus 127 times that. Times x plus, and then this thing plus 127 times the previous one. And then the remainder is this plus 127 times this, which should be 0, of course. So we evaluate this thing here, then that should be something close to 0. Minus 0.4, okay, well we counted that at 0. Now, what is this? 151 minus 127. That is 34? Minus 24? Yeah. So then this should have only two complex roots. Ah, yes, I see it. The 24 is the difference between 37 and 13. Except one had a negative sign, damage. Doesn't mean much. We could just change signs at will. Because that would only help if... where's my calculator? Nah, it's nothing. This number is way too big. Just plot? What do you mean just plot? Still trying to see the relationship with the minus 13 and the 37. That would be nice if it exists. This looks wrong. And this should be the product of all the three roots, which should be negative. In fact, 13 times 37 times 127 is minus this number. Let's just out. Yeah, seems to be correct actually, or maybe not. Because I just tried 127. Let's try the 37. 2, 5, 6, 7 times 37 minus 151 times 37 squared plus 37 cubed is minus 61,087. Then what about the minus 13? Minus 13 times 2, 5, 6, 7 minus or plus 151 times 13. Let's say minus 13 cubed is minus 33,605. We have found a failure. This is not the correct polynomial. Then what is it? 2, 5, 6, 7 times minus, no. Let's try 13 just for kicks, because what else can it be then? It has to be there, 13. 2, 5, 6, 7 times 13 minus 151 times 13 squared plus 13 cubed is, nope, it's not 13. It's impossible. Completely impossible. Yeah, but that's what I originally calculated even. Okay, have a look at it like this, it should be positive. Oh, it isn't, there is, oh, sorry, the minus is in front of it. Yeah, I remembered it wrong. This number is minus the three roots multiplied with each other. And if you add them up, 127 plus 37 minus 13 is 151. So this is minus the sum of the roots. And this is minus the multiplication of the roots. And this is like the sum of all the three pairs multiplied. Let's just try that. So minus 13 times 37 plus minus 13 times 127 plus 37 times 127 is 2567. Haha. Okay, so that is it then, because this 151 is minus the sum of these three roots. And I got that back here, the same number. Cannot be a coincidence. Meaning that the sum of the two complex roots, and they are conjugate, so the imaginary part drops out, is equal to 151 minus 127. That is C24, which is 2 times 12. That's where the 12 comes from. It is 12. So this 12 is half of the sum between these two. 37 minus 13 is 24 divided by 2 is 12. Now I want to find the imaginary part as well. Okay, how do I find this imaginary part? Now let's make it a minus, so it is the root is this, and then the other root is U minus IV. Okay, so how shall I call this? This polynomial is like the blah 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 of the other one. Not the conjugate, although conjugate means exactly this, but conjugate is too much used for flipping the sign of the imaginary part. Maybe it's some kind of synonym of conjugate. Could I call a cubic that pairs up with another cubic? A mathematical relation. Complementary. Yeah, not really. Which is the? Okay then. Let's just pick. Yeah, counterpart. Yeah, could use counterpart. Hello, Aman. Making. I'm not really making anything. I'm just musing over cubics at the moment. Well, I had a goal. The goal was to write the fastest algorithm to calculate the root of an arbitrary cubic. Let's call it counterpart. Is that one word? Building. am from the Netherlands. Okay, check one. This thing still should have an inflection point at 50.333. Yeah, better. So I did have values here. I think it just asks for it, right? Do that one. So derivative of this is 2x minus 24. What? Oh, wait a minute. I have to multiply this with... yeah, and then take the derivative. It's still easier to first calculate it, I think. Including that. Yeah, I need a second derivative. Yeah, that's correct. So 6 times 50.3333 is 302 minus 302 is 0. So the inflection point is still at 50.3333. But only as a single. I just guess that, I mean, if you could go this way, we can just multiply these things. Why would that not be the same then? I'm pretty convinced that I calculated it correctly already. However, it means that the somehow should arrive at a V of 97 or something. What was it? This 97.188. How do I arrive at that value? Assuming that ChatGPT didn't make a mistake. I'm pretty much convinced that it comes from, definitely comes from the length of the norm of the complex number, which is like, dude, multiplied with the conjugate, and you get the squared of the norm. So yeah, that is it. Should have everything to do with the fact that if we multiply this, we get to a certain number, and that number that should then, I suppose, have to do a lot with just multiplying all three. So if we begin with this, I mean, this is u squared plus u times iv minus u times iv, or the imaginary part drops out. Plus, well, I times I is minus 1, so the I drops out, is u squared plus v squared. Which is the square of the length thing in the complex plane anyway, and then I keep calling it a length instead of norm, so whatever. So, and then times 127 is something. And we already know then what it should be if this number is correct, namely 12 squared plus 97.1885 squared is a vague number. Now what happens if we subtract 13 squared from this and then take the square root? No, too bad. I hope to get 37. Yeah, I don't know. Squared plus 97.1885 squared. So some weird number. It's not even an integer. Oh, I recognize that here. I have a 12178. 217 something. Except what I have here is 100,000 times larger. Maybe I should, I don't know, maybe I should just try what happens if we set this equal. It's kind of the why not thing. Already set the sum equal, so why not set the product equal as well? And then go in the other direction again, instead of what I did now. Why would that not work? Maybe the problem is that if I do this, I mean, if I try to do what I did, I need to get this number, which we probably can't even find. Because I think this number came from the 13 and the 37 somehow. This number is the square root of this, where this is this divided by 3. It comes from the first derivative, so the 3 is understood. So where does this come from then? So this is the inflection point. We have a contribution to the linear thing here from the inflection point and again here. And this is this 151. This is by super coincidence the same thing. Why? No, this is also an inflection point ability. No, it's no. What? Where does this come from? Anyway, we also have a contribution this, which comes from it's just a linear coefficient, which is that weird combination 13 times minus 13 times 37 plus minus 13 times 127 plus 37 times 127. Very mixed up with this. So these values have a high influence somehow on this, obviously, which then returns as a factor of the xs here, which then results in this number. So maybe it actually did not make sense that I use that same number, because I don't think I could even reproduce it if we just have the counterpart. In other words, I'm gonna go for this route where I just said that the multiplication of all the roots must be the same. That's all the very fake, however, but u squared. At least we get an integer now out of it. That's a strong indication that it's better than what we had. At least I hope so. It remains to be seen. Times 127. Oh, and then it has to be negative. Really? The absolute value around it solves everything. It's 144, right? Nope. Okay, why would this always be positive? Yeah, it doesn't look very positive, does it? Say A is 0 and B is 10. Yeah, it's totally negative then. I mean, I don't know. Maybe you should not fill in V yet and just do the stuff and then see how V ends up in the end in the final formula. can delete this. It's had to do with the same factor, so yeah. Plus I forgot what to do. It's like random stuff. Okay, delete all this. So I just keep the V. I probably should write VI anyway, because it's the usual way people write it. The I at the end. And I want a dot. This times x and this times x, and then this times this. Quite a minus and kind of drops out. So minus VIX minus VIX, that drops out. So we get a minus 12x minus 12x minus 12x again. 24x. And this it becomes 12 squared plus v squared. Okay, let's calculate this. This whole thing times minus 127. That is... I'm not going to do that. Let's just... let Octave do this. Don't have a V symbol yet. Symbols a V. Try that again. Assign it. This is my new PX. I'm gonna call it QX. I'm scared to assign it to the same thing. Oops. And then we want to have this expanded. Expand QX. So I first simplify it. No, it's nothing to simplify. Expand QX is that. I just need it as a polynomial in X. Copy that because I can't remember it, of course. Yeah, imaginary numbers are super cool, Clement. Hi. So this is x to the power 3. Now I want to start with constants. So the constant here is minus that number, minus 127 v squared, because v is part of the constant really. And then the x and then the x squared and then the x to the power 3. No, we don't see a third power. Did we do that correctly? Minus 127 v squared. Minus 127 v squared. Plus x to the power 3. X to the power 3. Minus 151 times x squared. Plus x times v squared plus 3192 minus 18,288. Yep. So this is the companion or no counterpart of the previous one. Doesn't even look close like it. Well, I left the V. But it does look close like it because this is the same. The same. The 61,000 is yeah. So if you would be tempted to make this plus 61,000, that's impossible, right? That's impossible. Must be negative. So then you could be tempted to just make it a negative 61,000 because you have to lose the root somewhere. Can't remember that value. Kind of feels like maybe if I want to make it negative this, so this equals that. add 18,288 to both sides. And imaginary. No, it's negative, damn it. So remove the minus sign. Divide by 127. And v would be the square of that. Well, let's see what that is. 61087 minus 18288 divided by 127. Now we are talking. That's an integer. 337. And then the square root of that is not an integer. 18.35. I saw that before. Ah, that number. No, okay. So with this number, we would even get the same constant, but with a minus sign here. That's very tempting, isn't it? Very, 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 very tempting. Which is logical because it's exactly what I did here. I mean, that constant is the product of the three roots with the minus sign in front of it. And then again left the minus sign away because the thing has only one root. Okay. But yeah, I decided to keep the v for now. So, okay, get that. Continue with this, and then we continue like before. Next, we said, what is the first derivative? Blah, 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 and then we calculate xi, and that's going to be, again, 50.333. So I'm going to calculate the first and second derivative. The first derivative with respect to x should maybe use it, well, whatever. That is the first derivative. Which means that the second derivative is not changed. Thus, for the x-coordinate of the inflection point holds, blah, blah, blah. Same story, same story, same story. And then we plug that in. So let's just paste this below it. So now I'm going to talk about this and then plug in xs plus xi. Into the p of x. That will be this one. So it is that. Where my x is replaced with xs plus ix. Okay, the inflection point is filled in as 151 divided by 3. That is just the only replacement after this. Yeah, and then we have to work that out again. Zip. To the power 3. Symbol. To the power 2. Symbol. Multiplication. Symbol. Multiplication. Square. Square. Multiplication. And that is basically fxs. Just call it like that. fxs is that. Undefined xsy. Whoops. Okay, and then again, collect, expand. Let's do a simplify just because. fxs, expand, comma, collect xs. To the xs squared is dropped out now. Too lazy to calculate it. I mean, why not leave it like that? No. Okay, let's see if I did that correctly. This number divided by 27, there's a minus in front of it. Minus 230 v squared, then divided by 3. And then this is v squared minus that number divided by 3. Plus that. Yeah. What do you mean with embedding variable? You mean intermediate variable? See, from here I made a conversion such that this thing changed into a 3 or a -3. Well, this stayed molecule. There must be some kind of trick for that without calculating where the extrema are, because we don't have extrema at the moment. Don't have that. So instead, I want to go from whatever I have now to plus 3xt plus xt to the power 3. What does that mean? That word h, an intermediate thing here, g of xt. Yeah, that is scaled. That is scaled such that the extrema become plus or minus 1. But you don't have extrema. The only thing I know, the only thing I can that I hold on to is the vague recollection that my subconscious at some point had the insight that this sign had to change to a plus. I'm just going to hold on to that. This was already negative. And what do we have now? Could be negative, theoretically. Yeah, if I do that, then the V doesn't even matter. Hell, the way it is now, I could pick V such that this is 0. Why not? Make it easy. And then just do a cube root to calculate the excess. No, wait a minute, that's nonsense. V is determined, of course. V is fixed because the input is the polynomial. Sorry, the input is the third degree polynomial. So I can only change V to specifically talk about a counterpart of my previous example, and then see what the similarities are. But in the two examples. But I think the similarity is in the end just going to be that I want to do some kind of conversion where this changes into +3. And then I have no idea what V should be. I think it can be anything then, which kind of sucks. Nah, come on. Is that not... No, there's not. Wait a minute. Actually, there is. So if I set the derivative of this thing to 0, then we get a complex solution, plus or minus a complex solution. And I think that is pure imaginary as well. And then I just want that to be plus or minus I. I mean, why not? The plus or minus 1 was kind of arbitrary. Yeah, let's just continue the way like before. So here we just calculated the first derivative. Now, wouldn't it be nice to end up here with plus or minus that number times I? Total of that, really. Because I'm still holding on to the same scaling. Of course, this is counterpart, really. It's the only thing that makes sense if the scaling factor is the same. Which means that I would scale such that these complex extrema, whatever, wherever they are, end up at plus and minus I. And yeah, that would mean that this, without the minus, must be equal to the square of that. To put in words, I would like to have this equal that squared, which is It's something divided by 9 apparently. Just multiplied by 9, why not? Times 9. Where does the 100 come from there? I mean, I know where the 151 came from. You saw that before. Suddenly we have a 0, 0 there. Puzzling. To multiply by 3 on both sides. Dun, dun, dun. And then add this on both sides. Which is then this plus that divided by 3. Well, this is no longer true now. Now we want to have the square root of that, or let's first just calculate it, what it is. Damn it, not an integer. Square root of the answer. Oh, we saw that before. Yeah, that is what ChatGPT came up with. Well, after a question of me. So this is a good imaginary part apparently. Though I still fail to see how exactly I got that from the other stuff. Is it somehow related to the 18 something? Like maybe a factor or something like that. So this is now the answer, right? So answer divided by... And then we can't do it because you can't paste the number in here. 18.35756. I never got it. That was 35756. Nope. Nothing nice. Okay, so if we do this, I mean, as long as there's hope that we can find that number, then I'm happy enough. I mean, it doesn't really matter how we pair those cubics. Not really. They're not really related. It's just, you know, if you do, I don't know, if it might result in some more beautiful code, more symmetric code. More efficient even. Doubt that though. Just was hoping to see some beauty there. But let's just make a decision and set phi to this for this example. Clement, yeah, I do because it's mathematics. I mean two equal signs on one line. Yeah, well. It means equals. It doesn't mean a sign. It's mathematics. I mean, I also don't have stars for the multiplication. So I use dot and I use squares. It's not C++ code. I don't do double equals. And you can say that this equals that, and so on. Or just at most more readable if you put it on a new line. I want to fill in V. Do I want to fill in V already, or do I go one step further? Keeping the V. Yeah, I think I want to keep the V for now. Simply do a conversion to end up with a +3. So I'm having, what do we have? We have this. So in the end, that's some polynomial that you can write like, I don't know, let's call it a plus b x plus x to the power 3. And I want to do a substitution for x such that the b changes into a 3, +3. And the substitution is just just a multiplication. So then you get a plus b times that plus that to the power 3. Which is, well, the same thing, plus k to the power 3 times x prime to the power 3. We want to keep it monical. Sorry, I keep it in a monical somehow. I want to keep it monic. So you have to divide the whole thing by k to the power 3 again. Plus b divided by k squared then. It's equal to that, and then I want that b divided by the k squared equals 3 plus 3, which means that the k equals the square root of b divided by 3. If this is true, then the square is b divided by 3. We divide by that, so then it is 3 indeed, which means that we end up with a 3 here after making it monic by dividing by k to the power 3. So that drops out, this drops out, this stays whatever it is. And we got this by putting in kx prime for x. Yes. So forget about extrema, which don't exist, or the first derivative then for that matter. We're going straight to well, the next one is g, actually h, I think. Yeah, why not? H of xt. H is the monic one. So we're going to set the h of xt to that, which is my a, divided by some k to the power of 3. Plus this, wait a minute. This is b, it must be divided by k squared. Times xt plus xt to the power 3. Xt is the x prime there. Where then k is the square root of this divided by 3. Yeah, so if we assume that k is not imaginary, then this must be positive. If it would not be positive, then it would be negative, and then we would have a negative number here to the power 3 well, 1.5, which is an imaginary number, and that is definitely not going to happen. Thus, this is positive, so the square root exists, and taking the squares, then again, positive number. So this is positive, so this positive number here. So it doesn't matter that I take the square root and then square it again. Yeah, the other way around would matter, but that's just going to divide away, and then we end up with 3. Yeah. So divide by 3 is multiplied by 3, just simply what we want to get, 3.xt. And I'm dying to see this number, but then I have to pick a v. And the only thing for certain that I now can say is that v must be larger than the square root of this number. Yeah, but so v is larger than the square root of this number. Otherwise, the whole story would be nonsense to begin with. It seems like a very large number, by the way. But hey, 97 maybe. But then would not be larger. 13225 divided by 3 is that. Square root of that is 66.39. So the 18 is off the table. Therefore, we go for the 97. Let me see if I can find a relationship though with that 97. You never know. Divide by 97.1885 is no, still not a nice number. Yeah, well, I mean, we see this one back. We might as well pick it, right? I mean, it can't be the 18. So let's make it. Well, let's just pick v is that number. We had a reason for it actually, but I forgot the reason. How did we get this number? Oh yeah, that's that came from multiplication of the roots, right? That did have certain implications for the moment that constant still was. The multiplication of the 3 roots. That would be this one. No, it's not. Okay, now I'm confused. We got the 18 from that. Huh? There was another number that I wanted to keep equal. This comment is not correct, damn it. It was somewhere during my stream in the last hour, even a half hour, I think. Was it not maybe this one? Maybe this part. Let's calculate that. 2. $97.188.5 times 127. One 8288. Yeah, doesn't ring a bell. 30,630.9395. Yeah, the. Oh, I remember. It was the damn it. It results in having the solution of setting the first derivative to 0, having the solutions of plus or minus I. That's not this one. That it must be H. But I'm only 99% sure, so now we have to verify that again. No, doesn't make any sense whatsoever. Shit. The derivative of H doesn't have a V in it. Arg, where does this number come from? I think I'm gonna look back at my, I will never find that again. Gonna look back my own stream, because at some point I literally found this number again, and then I recognized it and said, hey, that's what ChatGPT came up with, at least as an answer to a question that I asked. We still have that, but this was a way. I still think it's kind of like had to do with that didn't have to do with demanding to have the same scaling factor, because this is like trivial, right? This first derivative of this thing is simply 3. Yeah, that's trivial. This is 3 plus 3xt squared. So for plus or minus I, the xt squared is minus 1, so then you have 3 minus 3 is 0. So that's what we actually worked towards to. That's what this is, which results in the same scaling factor. That was it. The same scaling factor. From where to where? So that's it then. The scaling factor came from yeah, that's what it was. Yeah, this is what I was doing. Complete fucked up. 13225 plus 15100. That divided by 3. Okay, whatever. 9441. Point lots of sixes. Is, and then the square root of that, 97.16. Oh. 8. Well, close. I'm going to say that this is more accurate. These are integers. Where does this number come from again? Integer. Yeah, this is Octave calculated this, so it's rational numbers. So that number is exact. So let's pretend that we never saw the number ChatGPT came up with. Probably that's the number. It seems I don't need the absolute value either. Oh, I just had it. 97.16823 squared minus 13225 divided by 3 is positive. Okay, so divided by 3 is that times 9. Yeah, okay. Totally happy. Don't need that. So now, finally decided on the value v, which means that now we can redo this all again, but then with the actual numbers. Thus, we started with this. Maybe just use the other calculator. I want to have this times v squared. I only have v squared. Dude, what? Walk. V squared is that. Hell. Just write it as something divided by 3. The something being 13,225 plus 15100. Yeah, I could fill in the v squared here or redo it. They could have made this a little bit more user-friendly, if you ask me. Well, that should be 127, right? So just very wide, like that. No, it cannot be 127. It should be 1.8 something. It's probably the same thing. I just solve it again, I guess. No, it just has to be this number here. This number. I'm just going to try and fill that in. E minus 11. Okay, that's 0. So that's correct then. As in the root is this. Yeah, and then from here on, it of course is the same. But you can just copy that. Apply. Get that one. And then shifting it back. So the reason we call this polynomial and the counterpart of this polynomial is because, yeah, well, we found the root of something similar, namely the other one has minus 3xt, which means that it has the extremes at plus or minus 1. And this one has no extremes, or if you must, plus or minus I, because I made it a plus 3. And the result, it has the same multiply. You have to multiply whatever the root is then that you found. You have to multiply with that with the same factor and then add the same sum. These two numbers are also the same. So I think they are really counterparts, as it were. Now I finally did all the work with an example. So now you would say I can do it in code. Maybe I should go straight to C++ instead of what I was playing with. I think I was playing with was transform.m, I think. Let's see what that was again. Yeah, this is not even the one that doesn't have roots. So if we would solve this and then multiply it with this factor here, and then add this one, then we get the roots back that it exists of. So maybe kind of interesting to do that and then add it to Git, to the project. Not sure I can use this as a symbol now, can I? No. Cool. It's really silly that it's in Princess, but okay. Okay, do the real parts like that. Nope. Beter. Substitute X as is that a K or something? Okay, so it's K. K substituted. Test case. K is and then we print substituted. Yes. Unterminated string a little. Right. Don't have an IX here. So I want to add the 50.333, which pops up here first. Substitute in the test case would be nicer though. Must be test case already. Substitute X. The VPA subs X subs. X subs is this. And it's actually should define the IX here. IX is I think the IX is the negative thing or the positive thing, so it must be the negative thing. And I want it to be replaced. Do I need a VPA? Probably. VPA subs minus that, comma, substitute subs and VPA. Now I can use IX here, I think. IX. Yep, and then we have minus 13, 37, and 127. So how do we round those things up? Yeah. How do I get Octave to print floating point numbers rounded to at most 6 digits behind the comma? I like that. It's kind of lame though. Okay, so now let's I'm not convinced I have to do this first. It seems logical, but yeah, I'll go with it for now, but still. I'm just going to calculate the inflection point without using my analyze cubic. So after this, yeah, we already divided by C3, aka I can treat C3 as being 1, so we just divide by 3. I really don't like dividing, but hopefully the compiler will convert it to multiplying with minus 1/3. Maybe we should just not divide by coefficient at all. Instead, multiply everything by 3. Because the amount of times that I saw divide by 3, it's like ridiculous. Maybe it would be a good thing to just have everything multiplied by 3. Yeah, well, I don't know. I don't know. Damn it. Ah, yeah, right. I can't do this really. I can't do this here yet. I need the formulas now. To know I know how it works. I still need to do everything symbolic. Otherwise I don't have the formulas. I was also doing it symbolic, I think, in the transform. So here, what is this? Symbolic, dangerous. What? Oh, this is an old one. Oh. Yes. Okay. Yeah, so I did a test case in order to follow what the f was going on, but in the end we just need the actual formulas, which you now know are correct because yeah, well, at least one numeric example and stuff worked. So I do need the inflection point, but that is this. And I don't really need the inflection point. Well, yeah, probably need it anyway. Probably need it anyway. Just to see if it is. No, actually I don't. I don't think I really need it. What I need is to fill it in and then get my transformed cubic. So we just shift. So I have this cubic here. And then we shift it by the inflection point. by replacing x with that, which gives this cubic. And that cubic has an extreme at k, or x is k, I guess. xs is k at this value. Do we do another substitution? And that fails. That is, Octave completely fails to simplify this. Because really, I think this whole expression here is 1 and this expression is 3, minus 3. And it doesn't see that, which is very annoying. Yeah, okay, so we do some trickery to separate them out. I think it takes 3 times the derivative to get this, the coefficient of this, and then we can simplify it, and then it becomes 1. And did this even though we already see that it was 0, and this is minus 3, and then the only thing that really matters is what the constant term is. I believe that this one is simplified. Test case, test case, test case. Yep, there is a test case. So this is the final thing, and it's actually the only thing I need then. Well, apart from the numbers that in between. So, okay. Yeah, okay, but we begin with this, right? So we begin with this. I need to calculate this constant. This constant I could construct from the C0 divided by C3 if we divide the whole thing by C3 cubed. Which means that we have a C2 divided by C3 cubed here, and a C1 divided by C3, and a C2 divided by C3. And then this is divided by C3 cubed, which I'm gonna assume results in C1 divided by C3 and a C2 divided by C3, all squared. Which is actually the same as just this expression where we do the division before that and set C3 to 1 in this expression. And that would be this thing here. So that thing should be equal to this. Although I'm not 100% convinced because of this to the power 3 too. I mean, if I divide up and up, is the coefficient. Okay, yeah, no, of course. Yeah. This thing here makes it so that if you want to divide the whole thing by C3 cubed, then you have to divide inside by C3 squared. Which then does exactly what you want. So divide this by C3 cubed means that in the end we're going to divide by it. And this divided by C3 cubed is 1, 2, 3. And this divided by is well also divided by, and then still cubed. And then this divided by C3 cubed means that you divide it inside by C3 squared. So you get something like divided by C3 then, and then all squared, with that squared, things still like that. And then we realize that we already divided all these coefficients by C3, so really this is just C0. That's my X here. This is just C0, and this is just C1, and this is just C2, and then this is also just C2 to the power 3. And then of course here again just C1 and just C2. But that must be squared, and then that must be to the power divided by 2. And my attempt then was here to do that. 27 times C0 minus, clearly we went wrong there. Which is a good thing, because it didn't work. Yeah, okay. The 9 is missing, and everything is missing. This must be C0. What the hell is this, man? Squared? Oh, wait a minute. Ignore me. I have this thing times C2, so we have C2 times C2 squared, which is C2 cubed, but there's still a factor of 2 missing. So let me just multiply this by 2 inside of it. So now we have this thing here is 2 times C2 squared, again times C2. And then this must be... That's wrong as well, there's a minus sign in front of it. Let's do a plus here. And then here we have just C2 times something times C1. It should be C1. Why is this multiplied by D? Oh, okay, now I get it. Yeah, sorry. Yeah, okay. Damn it. It's probably correct to leave the 2 away there. Let's fill this in. Let's fill the D in. So you have this, where the D is equal to this. And then here as well. Oh, and again. So this is now, oh, let me just get rid of the square here. So that one was squared, this one is squared. This one is squared. And this is now C2 squared minus 3C1 times the square root. So this is actually the whole thing times the power, times to the power, I mean 3 divided by 2. And you can multiply this one out or inside it, 3, and this is done times C2. It would be that part, I think. No, 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 no. Times C2. So this thing is times C2. And this is times C2. Really? Yeah, apparently. So now multiply the 3 in. It's this whole thing times 3. It means that times 3. And this times 3. And then the minus inside. That means that that becomes a minus till the division. Minus plus. And then I have a minus this, and again minus that. That's not good. It's going to be minus 4 times that. So it is not good. Yeah, hi Zas. Hey. You're right. That's because I wrote a square but not a cube. But I'm having a lot of cubes now, so I probably should just add a cube utility. Or maybe you just should use standard pow. I don't know how slow that is for integer exponents. The reason I hesitate to use the standard pow with a 2 as an exponent is because I felt like, yeah, come on. How fast? It can only get slower than multiplying 2 numbers. I'm not sure anymore that this was correct. So let's just start over. I'm gonna start over. So I think that I did this with Octave actually. So maybe I can do that again. So I just do it my way, as it were. So if d is the square of c2 minus 3 times c1, then this is d, yes? This is d. And here we have something that is a lot like it, except of course that we have to the power 3 here. But we can rectify that by, well, let me first put this minus 9 stuff on the other side. I really hate it. Let's replace this with a to the power 3 like that. So we can put braces around this and then multiply it with the C2 outside of it. Which means that this is gone and this becomes a square. And let's just use that. And I want to go to it towards d, so we have to divide the whole thing by 2, apparently, or multiply it by 2 rather. So dot 2. And then this one is gone, and this becomes a 4.5. And then we can change this one into -3 C1. Minus 1.5 C1. And then the C squared minus 3C1 is D. And this is 3 divided by 2. So and then we multiply the 2 back in. So this becomes a 3. And this becomes 2. This might have been my attempt. So now we have, well, this is the d times the square root of d. Yeah, that's this thing. It's 1 to the power 1.5. And above you have 27 times C0 something times C2, which is totally not what we want. That must be 2 times D instead of 3. And then we must subtract 3 times C1. Really? Okay, let's start over. Definitely wrong. That's what I made of it. I'll just hope that it is good. Okay, then we have the scale. The scale. It looks incredibly like D. Square root of D divided by 3. Let's see, where's my scale? Okay, this is the scale. Maybe I should have left it in. Let's leave it in now. Now let's divide divide this by C3, so that drops out. And then you have to divide this by C3 as well. Therefore we have to divide it by C3 squared. Yeah, let me just remove the C3 altogether actually. Just did already verify that is correct. Don't say much, but if we divide this whole thing by 3, then have to multiply this by 3 or internally by 9, which means that this becomes 3, and here just goes away, which is then c squared minus 3c1. Hey, we saw that one before. So this is now d. So that is just the square root of d divided by 3. And yeah, that's what I had already. That's the second time I calculate the square root of d, which I don't like. Square root of d is the square root of d. Screw this formula. I delete it. And then adding back, yeah, it's just a inflection point. So that is minus that. I already have it here. Actually, it's not minus that. So now what we really want to do is calculate. Oh wait, did I do this one? Yes, I did. Okay, so we want to solve the cubic of c0 minus 3 times x plus x cubed. Yeah, this depends on. This depends on something. Damn it! What does it depend on? Damn it! Yeah, of course. It depends on if this that's it called. This discriminant of the first derivative. If you set that to 0, is negative or not. which means that I'm even typing to see. 3 times x squared. Yeah, let me just remove the 2 here. Going to divide by 3 here. And then here I can just do c2 squared. And then so c3, c1. Which magically is equal to our d. Okay, this definitely needs more explanation. Actually, it doesn't. Yeah, so this is equal because C2 is now 0 after this conversion. Man, I so dramatically speeded this up. You have no idea. It took a few days, but now I'm starting to believe that this is going to end as the fastest root of a cube calculator ever. Like literally everything drops away. I mean, this was already changed. It was way more difficult. Everything becomes simpler and simpler and simpler. Look, like for example, these two are not even different anymore. Okay, so this works now for the case that we do have extremes. No, I can't even calculate this if we don't. So here I'm going to say if the cubic has local extrema, then we can calculate this. And yeah, this depends on the square root of d as well, so definitely also part of this. This starts to be just an annoying, sore old comment that takes a lot of room. Because I don't care anymore about if the extreme is a minimum or what. The shape is always the same. Ja, een beetje achterhaald dit, I think. Not using a cubic anymore. Absolute value. They're all const. Now I'm not sure I cannot reuse some of the letter code really. But. So if we do not have a local extreme, then we have to do something else. This is no longer correct. Everything changes. But once I have my C0, yeah, this would change. So that is that becomes a plus. And I could reuse that code, but then I have to pass in another variable for this one. But I guess I could do that. That's the only thing that changes. There's the first derivative, so that is also plus 3, I think. Yeah. Or isn't it? What is this? It must be the first derivative of f relative to x, which should be c1 plus 2 times c2 blah 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 equals c1 plus 2 times x. Okay, yes. And now we have a c2 is 0 in all cases, and c3 is 1. So we get 2 plus 3 times x times x. How the hell did I end up with this then? This is 3 times c3, which is c3x, or really it is just 3 times x, or this part anyway, yeah. Plus 2c, which is 0, times x would be this part. Oh yeah, okay, so c1 plus c1. C1 is the minus 3 here. So I could make this a variable called c1 at this point, why not? Or maybe a c1 transformed, not override the other c1. Can reuse this, provided that I call this C1. It's the only thing that changes, I think. It's always -2. Oh yeah, the EX swaps sign. So EX is either -1 or +1. So in this case it's +1 and here it's -1. For the transformed case. So if this is larger than 0, then the extreme is +1 and then we should use -2. Is that correct? The inflection point is larger than 0, we use -2. Yeah. Okay, so C0 is also no longer const. I need a double C0 and C1 here. This -3 is just that -3. Scale is also no longer const. Okay, now to figure out the formula for C0 and scale. I think I go to bed. Hazel's concept, yeah, well, it's a C++20 thing. I don't know where you encountered it though, in my code, because I didn't see you mention it at the moment that it might have flashed the past. Right. Yep, so that C0 is this constant. And the question is, where the hell did I get that from? So we need that one expressed in terms of the coefficients of the original. I think I just go to bed. I don't want to do one tiny test though, because yeah, currently it doesn't compile. I can comment that part out. So I'm gonna do let's say this doesn't work. And the rest should work. And I will not sleep better, even though I find out that it doesn't. But I just have to test it. I think that random cubics. Random cubics here has a thingy for. Well, that's a -3, so this definitely should have a root. But why the hell am I passing -3 here? Should do this one, right? But this one maybe has only one root. Or does it? This kind of seems to say that it has 3 roots, so I guess we'll find out. Let's try to calculate the 3 roots of that cubic. Drum ruffle. The accumulation of how many hours? Discord is above everything. 5.5 hours of work. No, there's only one root. And not, it is aborted soon as well. This is completely bullshit. It doesn't work at all. Damn it. Why? Okay, we should of course start with the cubic that I mangled. Which is this one. That one is already monic, but who cares? No. Yeah, this is the cubic. That 61,087, 2567, both positive, minus 151. Oh. Could be sweet. Oh. Okay, never mind. Never mind that. No, random routes. What the hell? I'm in the wrong window or something. Quit, yes. Go to random cubics and actually fix it. This was the square and then plus, I think is already monic, like that. Now please let it work, or maybe not, and then make it an easy bug. It's bloody working. These are the roots. Do I sleep better now? Not so sure, but the other one didn't work. So, what the F? Yeah, this one completely worked. Completely worked. I don't know. It's gonna take a lot of time, I guess, for another polynomial that didn't work to figure out why, because then I have to do everything by hand to check what it should be, and then you can compare it with what happens and stuff like that. Or maybe yeah, okay, let's have one more thing before I go to bed. It's always that one more thing, right? So this one did work. That one did not work. And maybe the reason is simply because I abort for the wrong reasons. Not something I would understand though, but we'll start drawing stuff then to understand it. Yeah, well, it finds a cubic and then it turns out to be only one cubic. Huh? That makes no sense whatsoever. I mean, it should have asserted if this is the case. So why is it not printing 3 of them? Is it a solution at all? Yeah, it has to be a solution. But no, actually, this is solving that the transformed cubic. So it's still interesting to know if this is a solution. I'm just going to do that the hard way. Times the solution. And the solution squared. Let's play it safe and do it between parentheses. And here we have, well, again then, because it is a negative number. No, that is 0, more or less. That seems to be a root, so why is it not returning the other 2 roots then? No, so the thing was already monic. 2D is... Oh! What? 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 Oh, never mind. Next, in D. There is D. D is positive. And, totally, yeah, it's not asserting for that reason, but it also means that we have extremes. So it means... Oh, never mind. We have extremes. That doesn't mean that we have 3 roots. No, of course not. Okay, yeah, cool. I think I get it. Let's see if I understand that as well. So we have the inflection point. Wherever. And now we have a G0. Whoa, so big. Big. So it is extremely far below the x-axis. That's why we have only 1 root. Yeah. Maybe I do understand it. Maybe I do understand it. So I did abort because the step becomes larger. But if we are so close to the inflection point, which has a... No, we're not super close to the one of the extremes, because it does have extremes. That it's kind of logical that if you go further away, the thing gets way more steep. And no, it does not make any sense whatsoever, really. It doesn't. Not getting it. But okay, that's for tomorrow. And then after this, it does become even bigger. Delta step becomes bigger and bigger. Maybe it's an Haley thing. Instead of, I mean, no. Really? It gets just bigger and bigger. And bigger. And bigger. And bigger. Talking about having the wrong starting position. Now it becomes smaller. Finally. 31. And that went fast. Step of, if you see like step of 193, step of 31, step of 0.06, step of 3.5 times 10 to the power minus 10. Talking about zooming in. And we're there. Okay, I'm just trying to calculate the root source quadratic, and then that doesn't have any. Yeah, logical. Okay, I'm getting it. It seems to work though. Ta-da! Well, it's for 2 cubics. It works for 2 cubics, and I'm convinced that now we have all the formulas correct. But still not the termination condition, and maybe even the starting condition. Maybe even the starting condition is not right either. But I thought it would just make smaller steps. Period. So I definitely have to look into that, so I understand why the step gets larger, so we can avoid that. No, brilliant. Time to go to play chess. Go to bed, please. It should go to bed. Definitely. It's not even midnight yet, so who cares? Let's lose a game of chess. I'm below 1900 again. Still stuck at this low rating. Well, low, yeah. I want 50 points more, really. Seriously, at least. Okay, this beast is called Sicilian, and he didn't play anything related to this square. So what to do? No, this, I guess. I did block my bishop for the possible exchange now, but I would only want to exchange if he plays this, and he won't play that. Oh, wait a minute. He played it. Interesting. Yeah, no, yeah, well, interesting. Okay, move my knight, I think is the best thing, and then if he takes, I take like that. And then I would like to have a major attack on something, but I don't. Take. It's not blocked. I have the bishop is attacking that point as well, but he's also defending it twice. My bishop should really get there though. Yeah, I'm not going to take. Then this backwards pawn is gone. But if he takes, and this one is also not very strong. I think I have to go here. And he can pin it. Maybe I should go here. There's not much future there for my knight though. I'd rather go here in the end. Maybe I should go here. Oh, that's an idea. Yeah, he's not taking me. He's just refusing to take it. It's pretty annoying. In the meantime, I can't develop my bishop. Shit. No, let's play this knight then. Doesn't feel very good either, but I'll have to anyway, I think, to defend this thing, which was attacked twice. Now we can play my bishop. Let's do that. Defend this one again. I don't know why he did that. Looks like a not that good move, actually. Let's play this instead. Let's go here. Okay. Can do that. Was almost a waiting move, hoping that he would go there. Ah, bloody hell, he didn't do it. Okay, let's just go here. Now what? Now he's going there. See, now I didn't waste a move with my bishop. Ha 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 ha. And that one is attacked 3 times now. Seriously. It's pretty annoying. And he leaves his king in the center. I push this one, he takes here. And I take here, and he takes there or there. Nothing. Just lose a pawn. Was probably not a very brilliant move of me. "55 seconds left." No comment. Absolutely no idea what's going on. He thinks he can win on time or something? No. Resign. I don't know. That was a mouse sleep kind of thing. Damn, what the hell. I don't want to win that way. What? What bullshit is this? Sure, it's another one. M8. And I get more points because he wants a rematch. It's a child, I think. A young child. Put a queen there. What? Punish him. Punish him or her? Nobody knows. Yeah, just develop, I guess. Would like to get a center like this. No, he takes take and he takes your check. Let's castle. Now I could do this. Threaten to take here. And if you push, I just take the pawn. If you take like that, I take like this. I can't take here because it loses the queen. Give me the center. I want the center. Okay, it's planning to do this. I just have to develop more pieces. I don't care about those pawn moves. Few pushes I must take. Might as well start running immediately if you ask me. Push this pawn maybe. Two piece. Oops. I can take it. But he takes back, we jerk. I don't care about it. Nobody's gonna touch this thing, right? Such strong moves online. I'm dead, man. I'm basically dead. One minute left and I had to give away quality. Ah, could have taken the ball. Why didn't I? Oh shit, really? I can go here. Ha 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 ha. Shit. It's actually not that bad. Should first push this one. Or do I need my knight? Is that a problem? Damn it. Do something. I just give this pawn. It's a double pawn anyway. Who cares? No time left. It's gonna take here, unfortunately. But or not. Still thinking. Yes. Let's give a check here. Never make it. Oh shit, got to check here. But I still can't take it because then I take that. But then he can take this, so I'm fucked. Oh, not really. You can still go here, let's go there. But it's not good. It's definitely not good, this. Can't give check. Threatening to go here. He's gonna go back. And then I do this anyway. Haha, and I win the bloody rook. Probably win equality. I don't really care where he goes, I think. It's a check, I take the rook. Otherwise, I go here. If it's a check, this is an illegal move, so I can pre-move it, yeah? And then, of course, you take here. No, he's gonna call like this one, maybe. He's not. Okay. I could go here. So the night is protecting the square. Yeah, let's go to bed. I brilliantly got higher than 1900 again. Good night.